So we're going to go over some examples for the circular curve element. So the first one that we have a simple curve. We have a straight line coming in and a straight line coming out. Where those two intersection angles touch, it's called the point of intersection. Now at the point of intersection, this internal angle, intersecting angle here and here, is going to be 8 degrees 24 minutes. Now the PI station here is 64 plus 27.46. Basically, a surveyor has staked a straight line in, turned the angle, and staked the straight line out. Now, what we're going to have to do for the engineer side is we're going to have to figure out from that PI, when we set that radius, what the PC is. We'll have to figure out the length of curve and set the PT. Okay? We only station up to the PI for the surveyors, but then we have to restation to get to the PT because we can't go up and then turn an angle in designing. Now, they want us to calculate the PC and the PT stationing and the circular curve elements. The tangent, the length of the curve, the degree of curve, the long chord, the external and the middle ordinate distances. Now, what we're going to do is we're going to take a look at, and the radius by arc definition is 2,864.79 feet. So what's in red is what's given to us out of this curve. So we're figuring PC, PT, tangent length of curve, the degree of curvature, the long chord, the external distance, and the mid-ordinate distance. So let's get started. These are also the symbols that you'll see as we go through. What I'd like you to do when you all do your homework is write it up like this, so you'll know the equations that you need to use and then how to plug them in. So the first equation we'll use is the length of curve is going to be 2 pi r over I over 360. The I over 360 allows us to convert it from radians to degrees. So we can use the I actually in degrees instead of radians. Now the tangent length is the radius times the tangent intersection angle divided by 2. The PC station is equal to the PI station, this station here, minus the T. Now, typically we're going to do these calculations in a specific order because we have to know one piece of information before going to the next. The long chord here, this orange line, the long chord is 2r sine of the intersection angle divided by 2. The degree of curve, note that it's in degrees, is 100. The 100 means that I'm going 100 feet. This distance from here to here is a length of 100 feet, arc length. I over L, I over our length of curve. Now our PT station, this station here is going to go from PC length of curve the length of curve added to the PC. The mid-ordinate, and we're just going to use the equations from before, we're not going to do all the trigonometry to get to that point, is going to be radius times 1 minus cosine I divided by 2. And the external distance is going to be the radius times 1 over cosine I over 2 minus 1. So we're just going to plug in equations. So write down your equations that you need, and then you're going to start solving for them. So the solution is L 2 pi r I over 360. I plug in the radius, I plug in the degree of curvature, the intersection angle, and I get a length of 420. What I'd like you to do is go ahead and use your calculators and make sure that you can use the same formulas, get the same answers. The degree of curvature, or degree of curve, is 100 divided by times I over L. So 100 times the intersection angle divided by 420 is the length of curve. It gives us a 2 degree. There should be no minus sign here. It should have been an equal sign. Tangent equals to the radius tangent I over 2. So the radius is the 2,864.79. Tangent intersecting angle, 8 degrees 24 minutes divided by 2 gives us 210.38 feet. So that's the distance from PC to PI. Now, we're going to start calculating our stationing. The stationing says, okay, the PC is, I'm going to take the PI station and subtract the tangent length. The PT station is, I'm going to figure it from the previous PC, I'm going to add the length of curve. So the PI station is the 64.2746 minus the 2 plus 1038 is going to give me 62.1708. That's the stationing here. You can say the pluses in it, but I'm just going to say the numbers as I go along. Now I'm gonna add that length of curve here, the arc length of 420, and that's going to give me a PT station here of 66 plus 3708. Now my long chord here, long chord is going to be 2r sine of intersection divided by 2. I plug in my equation and I get that long chord to be 419.62. Now,
Quick question. If, for instance, because the tangent is the same, right?
Mhm.
So if I have the tangent and then I get pi, subtract tangent to find PC. If I get pi and add tangent, I'll get PT.
no,
the
you
same
will
or
not.
No.
No, because here's the thing. The tangent, good point. The tangent length is 210.38, right?
Yes.
The actual length of curve, the L,
It's 420.
is 420. So there's no way that you can add 210 back to that PI
And
station
get the
to
same
get the
result.
same number.
Okay.
It has to be the actual length of curve.
Okay.
That's why I said at the beginning, when you're building the road, you can set up the PI based on the survey's direct lines, and that's usually what they do because the surveyor doesn't know. They just know where the PI is going.
Okay.
And an engineer comes along and sets the radius. As soon as the engineer sets the radius, that PI point does not exist. It exists in the survey world, but in the engineering world, we figure out PC and then figure out the length of curve to PT.
Okay.
But yeah, no, exactly. I've had many students do that, and no, we can't use that. We can't use that. So we have to do PI minus PT, we get PC. PC plus the length of curve gives us the PT. So now we've got our long chord here. We're going to figure out the mid distance. So we're going to use the radius times 1 minus cosine I over 2, and we're just going to plug this equation in. Now here's where I say again, make sure you know how to use your calculators to do this. If you have any questions, send me a message. Okay? So that mid-ordinate distance here is 7.69 feet, and then the external distance is R1 over cosine I2 minus 1, and that distance is 7.71 feet. Just plug the equations in, all right? That's why at the very beginning, I show you all the equations that you're gonna use, and then you're all gonna plug them in, all right? Now, I'm gonna show you another example, but I'm gonna pause here.